Okay, in this lecture, we will be talking about confidence interval estimation for population mean mu when the population standard deviation is known. So we will assume that we don't know mu, but we know sigma, and we want to use sigma and other things, of course, to find an approximation to mu. The picture that you see here summarizes the whole process. And at the end of this video, please come back to this picture and make sure that you understand it 100%. Okay, so before I start, I want you to know something. Did you know that the attention span of human beings is between 10 to 20 minutes? But what is attention span? It's defined here. It's the amount of time spent concentrating on a task before becoming distracted. So for you as a student, usually you are in the upper part of this. You should have an attention span of 20 minutes, let's say between 18 and 20 minutes. So try to take regular breaks every 20 minutes. This is not an accurate thing, because here they tell you there is no empirical evidence for this estimate. People still can choose repeatedly to refocus on the same thing. That's fine, that's good. But I suggest 20 minutes. So if the lecture is for 1 hour, then you watch it in 3 parts at your pace. Okay, so let's start. I first would like to remind you of the central limit theorem that we discussed in the previous lecture, and we solved exercises on it. Remember what it says. We will do the following. So it says that so first you have a population, as you can see here. This is my population, and this is my sample. And you know that in inferential statistics, what we usually do is from the population, you choose a representative sample, and then you use the sample statistic that you compute. We are doing the sample mean in this case, and you use it to infer something about the population mean. This is one of the things of inferential statistics, one of the things that inferential statistics help you do. You can also do it from the sample standard deviation to get to know things about the population standard deviation. Okay, and so now I want to remind you of the central limit theorem of the last lecture. It said that if your population has any distribution, it doesn't matter. But as long as your sample size, you choose a sample size that is bigger than or equal to 30, then you can apply the central limit theorem. It works in this case. Okay, that was the first part. But what does it say after? Okay, so we are able to apply the central limit theorem, but what does the central limit theorem say? It says that your distribution of sample means, x bar, is going to follow an approximately normal distribution. Okay, and the second part of it that we took as a second part, okay, was that if you started with sorry for this. So if you started with a normal population, a population that is normally distributed, then it doesn't matter whether your sample size is less than 30 or bigger than 30, the central limit theorem is going to work. And so this is what it means, but it will be precisely normal. So there is no approximately normal here. It will be precisely normal. A question that you might ask, like, when doesn't it work? Can you guess before I put it? So if we have what, then we cannot apply the central limit theorem. Easily, you can see that if you start with any distribution and then you take a sample that is less than 30, then you cannot guarantee that the central limit theorem is going to work. It will fail in most cases. Okay, so this is just a review of the central limit theorem. Let's now see what we will do. But before we see it, I just want to remind you that the central limit theorem, if it's okay, you see, if it works, then we know that the distribution of sample means x bar will be approximately normal. This means, by the way, that everything that you see here on the horizontal axis is an x bar of some sample. Okay, but you need to choose samples of the same size. So let's just say that we take samples of size 30 or more. You can take 36. You know, when you take samples of size 36, it makes it easier to do calculations, because when you do the standard deviation, look, this will be sigma over radical 36, but we know radical 36 is 6. So it's just an easier number. Okay, so I suggest that when you choose samples, just choose 36 to make the calculations easier. Remember also that we saw that the mean of the sampling distribution of sample means is the same as the population mean. Okay, so mu of x bar, so the mean of sample means is the same as the population mean. In this lecture, please always remember that this will be an unknown for us and we want to find it in this lecture. Okay, in the previous lecture it was given to you. Also remember the standard deviation, which also we called it the standard error of the mean. Remember what is a standard deviation? When you go down, it's exactly one step away from the mean. So you have 1, 2, 3 standard deviations to the right and 1, 2, 3 standard deviations to the left. But what's important is, what is this standard deviation? You compute it by taking the standard deviation of the population and divide it by the square root of the sample size. Okay? This is just a very, very quick review of central limit theorem and what it told us. So now we want to apply it in some situations in order to approximate this population mean. Okay, sometimes we might not have it. Let's say you lost the population mean and you have the population standard deviation. Even though you know that if you know it, then you must know mu, because when you calculate the population standard deviation, you use the population mean to compute it. But here, let's assume, just for this lecture, that we don't have this, or we lost it, and we still remember what is the population standard deviation, and we want to use it to recover our population mean. Okay, good. Now we will see an illustration of the idea of this lecture. So suppose that we have 4 female students, Meitha, Hissa, Sheikha, and Mahra. Okay, those 4 students decided to approximate the population mean for some population that they're interested in. It could be Zayed University, Abu Dhabi students, or it could be all the population of the UAE. It doesn't matter. But let's say that they all agreed that their sample size will be 30 or 36, let's say, just to make things easier. Okay? So this means that the central limit theorem can be applied, and also they know the population standard deviation. And the unknown is the population mean. Let's see what they will do. Okay, so let me just erase the things here. Yeah, but I'll keep the sample size. Let's just have a different color for it. So this sample size, all of them are going to use it. Okay, just remember this. They have to agree on just one number for the sample size, and then each of them will go and ask 36 other students about whatever question they're interested in investigating. So Meitha decided that, before I tell you what she decided, notice that all of them will have, and they want to use the same as the standard error of the mean, or the standard deviation of the sample means. Because the n is the same for all of them, this number will be the same. And because sigma is known, we said that already, so all of them will have sigma x bar. This will be given to all of them. Okay, good. So now what they will do is the following. Maytha chose to take one standard deviation away from her sample mean. So notice here that the sample mean of Maytha is different from the sample mean of Hissa, is different from the sample mean of Sheikha, and it's different from the sample mean of Mahra. So because of this, let's say, for example, that the sample mean of Maytha, okay, so I will start with Maytha, then Hissa, then Sheikha, and then I will go to Mahra at the end. Okay, remember the order. Okay, so Maytha took one standard deviation away from her sample mean, Hissa 2 standard deviations, Sheikha 3 standard deviations, and Mahra decided to take 1.5 standard deviations, 1.5 standard deviations away from her sample mean. And now, what they will do, first Maytha is going to take her distribution around her sample mean. She will just assume that she has an approximately normal distribution around her sample mean, and then put it where her sample mean is. So before we put it, let's say that her sample mean is here. This is the x bar of Maytha. So look at what Maytha will do. She will take this picture and put her sample mean exactly on top of the sample mean in the original picture. Notice that the population mean is in pink. You can see it, but it's not inside the interval that Maytha chose. Maytha chose to take an interval that has one standard deviation away from her mean, and it wasn't there. But if it was so that her sample mean was, for example, here, let's say that here was her x bar. Her x bar could be anywhere, okay? She doesn't know exactly where it is, but if it was there, then she will put it, and notice now that mu is inside the interval that she selected. Okay, now what is special about the interval that Maytha selected? Let's see. It is, we know that if we go one standard deviation away from the mean, then the empirical rule tells us that there is approximately 68% of the area is there. So this, we will call this eventually, we'll say this is the 68% confidence interval. It will be this. How confident is she that when she puts her sample mean on this picture, that the pink line will fall inside her in her interval? She could have it here, and so she will not be successful, or here not successful, here successful, here successful, here not successful, and so on. So she took 68%. So you see, 68% gave her a small interval around her mean. Always they will take the interval centered and at their sample mean. So now let's see what Hissa is doing. Hissa also will do the same. Will go find where her sample mean is, put it, but because her interval is large or larger than Maytha, the chances are that the pink thing, the pink tick mark where the mean of the population is, will fall inside her interval. She has a higher chance that it will fall. It could not fall like this. If her mean was here, then it will, then mu will not be inside. But if she is anywhere from here to here, then her mean, her interval will contain the population mean. So she can be more confident than Maytha of this. And remember, from the empirical rule for Hissa, when you go 2 standard deviations away from your mean, of course on both sides, sample mean on both sides, then you capture about 95% of the area. Of course, it was 95.45, yeah, but let's just make it simple, say 95. Remember the empirical rule, usually people refer to it as the 68, 95, 99.7% 100% rule. Okay, and of course Sheikha took the last one where she is 3 standard deviations away from the mean. So look at her chances. The chances are that if her sample mean is within 3 standard deviations from our population mean that we are trying to estimate, then she will contain it in her interval. See, unless she falls outside 3 standard deviations away from the mean, then the population mean will not be there. Okay, and remember from the empirical rule that for Sheikha, if you go 3 standard deviations away from the mean, she captures 99.73%. Let's say just 99.7. And the last one is Mahra. Let's see what Mahra is doing. Now, Mahra chose to take 1.5. So here, from here to there, is 1.5 sigma x bar. So let's see what happens with her. Can you guess how much confident she would be? So let's see. If she puts it here, not put it, of course she will go and check where is her sample mean. So for example, let's say her sample mean turned out to be here. Then she will just put the sample mean on top of where it is, and notice she will get the population mean inside the interval. But if instead, let's say her sample mean was here, this is Mahra's x bar, then unfortunately, if she goes here, she will not contain mu inside her interval. Now we want to answer the question, what about the percent? How much percent is this for Mahra? Okay, what we know is that she is 1.5 standard deviations from her sample mean, from x bar, and we know that the distribution is approximately normal, and so this means that if we want to get the percentage, this means that we need to find this area to know exactly what her confidence level will be. So what is this area if you are 1.5 standard deviations away from the mean? Remember, the empirical rule tells you about whole numbers. If you are 1, 2, or 3 standard deviations from the mean, then you will get 68 or 95 if you are 2 standard deviations, or 99.7 if you are 3 standard deviations from the mean. But what about Mahra? Now we want to know how much percentage is this if you are 1.5 standard deviations. So let's use the online calculator. So to use the online calculator, you want what? You have, you can choose area from a value, because you want an area now. The area is the probability. So we can do it with the mean and standard deviations of the standard normal distribution. And we want between minus 1.5 standard deviations and 1.5 standard deviations, and calculate. So it's telling us that Mahra can be 86.64% confident. So let's put it here. So Mahra is 86.64% confident that her sample mean and her confidence interval around her sample mean will contain the population mean. Okay, just like the other ones were 68, 95, and 99.7% confident. Okay, so this is good. Let's now go to the next slide. But in the next slide, you will see something new that I thought about doing. The Ministry of Education contacted me and told me that you are not a very good teacher. So how about you let Leonids, who is one of the best students in Zayed University, teach the students instead of you. So I said at the beginning I was against the idea, but then I thought like, okay, let me check. If Leonids can make you understand it, all what matters at the end is that you understand. So let Leonids teach you. Now, I cannot speak in a female voice, but you just imagine that that Leonids is speaking to you now. And at the end of the lecture, you let me know if you prefer Leonids or you prefer me to teach you. Okay, so let's see what Leonids is telling you. Leonids has a task that she wants to do. So she's telling you, I will be teaching you how to find a 95% confidence interval to estimate the mean grade of Zayed University students on the MSAT. Okay, so you know what is the MSAT. This is the MSAT. It's the Emirates standardized test. And her aim is to approximate or estimate the mean of the grades that students get. You know, in order to be enrolled at Zayed University, you must get a specific grade on each of the subjects. Okay, so let's say that we are doing the English, for example. You have English, math, chemistry, and physics. But let's say that Leonids is interested for now for English. Okay, so Leonids, of course, is very smart. So she goes to the university website and she looks at the number of students that are enrolled in Zayed University. She looks at the undergraduate and the academic bridge program enrollment in Abu Dhabi campus. What she noticed is that in fall of 2018, there were 6,367 students. And she looked back at the previous years and took note of how much or how many students are new students that they get at Zayed University every year. So she noticed that about 650 around that. So she added to this 650 and she got approximately 7,000. Okay. Of course, it's not exactly 7,000, but she thought that, okay, it might be 7,000 students. So she's telling you now, in fall of 2019, we had approximately 7,000 students in Zayed University, Abu Dhabi campus. Remember one thing about Zayed University? We have 70% of the students female and 30% of the students male. This is in Abu Dhabi campus. Dubai campus has all females, no males. But now we notice that the number of males is increasing in Zayed University year after year. So this is good that we have it. So eventually, probably, this will be 40 against 60. Or if we have more girls, then maybe they can keep it at 70-30. So now let's see, what would Leonids do now? So her aim is what again? She wants to teach you how to find a 95% confidence interval. For what reason? Is to estimate the mean grade of Zayed University students on the MSAT. But she is not very happy with something. She is crying now because she tells you that we lost the mean of the MSAT. This is the population mean mu. We lost it. We don't know what it is. We don't remember if the scores were normally distributed or not. So this means that if you want to apply the central limit theorem, you have to make sure that your sample size is bigger than or equal to 30. Otherwise, you cannot do anything. So Leonids is aware of that because she's one of the best students in Zayed University. But she's telling you now that she's happy with 3 things. So let's see what she's happy with. She told you that we did not lose the population standard deviation sigma. So sigma, we know it. The population standard deviation is given. That's why she's happy. And she's telling you exactly what it is. It's 150 points on this standardized test in the Emirates. And now she says, let me show you now how we can estimate mu, the population mean, using a 95% confidence interval. And how do we interpret the result once we get it? So please now get ready to start paying 100% attention to Leonids. If you feel that you're tired or you cannot pay attention now, please pause the video and come back when you are ready. But come back and read this slide before you go to the next one. That's according to Leonids. Okay, so now we will start doing what Leonids is trying to do. So now she tells you, we chose 95% confidence level. That's the confidence level, we denote it by C. And so if you say, I want 95% confidence level, you set C equals 0.95. Leonids also is trying to tell you that we can also use the significance level. There is something called significance level, which is 1 minus the confidence level, and we denote it by alpha. Alpha is the A in Greek. It's the same as A. Okay, so we know that alpha is 1 minus C, so it's 5%. So either you say, I want confidence 95%, or I want significance 5%. They are the same statement exactly. So in order to solve this question, the first step that Leonids will do, so now she's telling you, I will show you now how to find the critical value for 95% confidence level. This critical value, pay attention to Leonids now. What she wants to do is she wants to find the two z-scores from the, of course, this is the standard normal curve where mu is 0 and sigma is 1. So she's trying to find these 2 points that are symmetric around the mean of the standard normal curve, so that the area between the two is 95%. So this is her aim now, to find the z-scores. That's the first step after you define your problem. So she wants to find the point here and the point there. But at the end, she only is interested really in the upper one. You will see why. In computation of confidence intervals, you only need the positive one. So this is usually referred to, before I actually tell you, how about you understand this? This is C here. You remember C was 95% or 0.95. So this blue area is 95% of the total area. This means that the leftover area now, the one here and here together, will give me alpha. So alpha is 0.05, 5%. Remember, alpha is 1 minus C. And so 1 minus 0.95 will give you 5%. And remember, we call this the significance level. Significance level. And C, we call it the confidence level. So this critical value that Leonids is trying to show you is usually denoted by Z sub C. This C is from confidence, because the confidence here. So this means that this Z will write it as Z sub 0.95. It's written like this, or you can also write it as Z sub alpha over 2. Why do we say alpha over 2? It's because what is the area here? If you take just one of the two tails of this standard normal distribution, the two together is alpha. The two together are 5%. So one of them is alpha over 2. And so this will be 0.05 or 5% over 2. And if you divide 5% by 2, you get 2.5% or 0.025. So we can write it like this as Z sub 0.025. So in some books, some authors like to use Z sub C, and in other books, authors like to use Z sub alpha over 2. So you can ask me, which one are you going to use? How about we use both of them? Because you understand, Leonids is telling you it's very easy. Alpha and C are very easy to get. If you know alpha, so if this is known, then you can get C as 1 minus alpha, okay? And if you know C, then you can get alpha from C as 1 minus C. So it's very simple. Now, how do we find this critical value that we call Z sub C or Z sub alpha over 2. Exactly like we solved the question for Mahra. So what we know is that we have 95% area. Actually, it's the opposite to that, because now we have the area, and from the area we want the Z score. So we will go to our online calculator. Leonud is going, of course, not me. And she will do value from an area, and she will say that my area is 0.95. That's the confidence level C. And then if you are given, or if you have the confidence level and you want to find the critical value, you need to do between. So it's giving you, it's between minus 1.96 and 1.96. So this means that this negative Z sub alpha over 2 is equal to minus 1.96, and this Z sub alpha over 2 is 1.96. Really, this is the one that we're interested in. As I told you, you will always take the positive one of the two when you're doing confidence intervals. Notice also that you can use Z sub C and call it this, so it will be 1.96. You can say Z sub C is this, and let's highlight it also. Whichever notation you want to use, but just be careful, because textbooks, different textbooks use different notation, either this or that. But Leonud is confident that you will understand it. In this case, she's 100% confident that you know that whether you use Z sub C or Z sub alpha over 2, you get the same answer. But Leonud also want to draw your attention to something else. What if you want to use alpha? Alpha is the area, the total area here and here, together. So you can put here 0.05, and then you put outside. Notice you get exactly the same answer. Okay, so you choose. Leonud now will give you the option to choose whether to use C, the confidence level, and between. Of course, confidence level you need to put 95, okay, and between, or you use the significance level, which is 5%, and you do outside. In both cases, you must get the same answer, of course, because they are the same Z scores. We're just computing them differently. Okay, so now that we know, let me just write what Leonud has found. She found that our Z sub alpha over 2 equals, also we call it Z sub C. For this lecture, I will always say Z sub alpha over 2 equals Z sub C equal, and then I will tell you it's 1.96. In coming lectures, we will just use one of them. Whichever one we use, please be happy with it, because it's so simple. Okay, so now that we know this, how would she continue? Now pay attention to her carefully. She's almost done. Maybe another 5 minutes and she will reveal to you how are we going to estimate our population mean score on the MSAT using sample statistic. So using the sample mean. Now she's telling you, so far we found the critical value for 95% confidence level, or we can also say 5% significance level, and we computed it and it's here. So she recorded it here. And she's telling you to remember something, but I already said it. So you can read it later. But look now. Now Leonud is telling you that I will take a simple random sample, and usually we denote it SRS, from simple random sample, that is representative of Zayed University students. For example, it will have 70% females and 30% males, because Leonud knows that this is the right female-male ratio at Zayed University. Now Leonud is very smart, so she will take her sample size to be 36 students. And so that what? Why? So she can apply the central limit theorem, as I told you at the beginning. So now she says that she will compute her sample mean. She found, of course, she has 36 students that she asked, about 25, this means that about 25 of them females, that's 70%, and 11 males, That's 30% of 36. So let's write 11 good. Okay, so she will ask 25 females and 11 males. What I mean by what she means, sorry, by simple random sample is that she will choose her sample to be representative and random at the same time. So one way is to, for example, let the computer generate it. Like she has the list of names of all the students in Zayed University Abu Dhabi campus. She will just pick 25 females at random and 11 males at random. And then she will ask them one by email, let's say, what was your MSAT score before you joined Zayed University? Then she will take all these numbers, add them up, and divide by 36. So this, let's say she got X bar, which is the sample mean, to be 1,315 points. And remember, she's reminding you, our population standard deviation is 150 points. So these are very important numbers. Now we have those three numbers, and we can listen to Leonids teaching us how to use these three numbers in order to find the 95% confidence interval. Of course, we will need this too. We need it also. Okay, you will see. So put a happy face, because we computed it and we know how to compute it for any confidence level, or if you like, any significance level, whichever one you like. You like to do significance or confidence, it doesn't matter as long as you get the right number, and always take the positive Z. Okay, good. So let's go to the next slide, remembering these numbers. So her X bar was 1,315. This was points, of course. Now, what is her standard deviation? Let's change the color so that you're not distracted. So her sigma X bar, or the standard deviation of sample means, is sigma. Remember what was sigma? 150. So it's 150 divided by the radical of her sample size. Remember, her sample size was 36. Very nice. So this will be 150 over 6. And if you do it, I believe you get 25. Yeah, you can check on your calculator. Definitely it's 25. So now, what does she have? She has the sample mean, and she has the standard deviation of sample means. So she now wants to create her 95% confidence interval. Look at what she will do. She will go to where we have 95% at, remember it was approximately 1.96. So she will take 1.96 times this number. Okay, so she will get here and here. So let's see what she will get. This number will be the Z score, the critical value, times sigma X bar. And it was 1.96 times 25. 25, we just computed it here. So let's see, 1.96 times 25. Okay, 1.96 times 25 equals 49. Nice. So she knows that this is 49. She wants to tell you that there is a name for this when you multiply the critical value by the standard error of the mean, or the standard deviation of sample means. This is called the error. It's called this is called the standard error, and this one is called I just forgot. It's a very easy word. It's called, let me just find it, margin of error. Sorry for this. Yeah. So Leonids found that this is found the margin of error. This is called margin of error, and it's defined to be the critical value times the standard deviation of sample means. And so it was 49. Okay, what does this mean? It does. Oh, by the way, this doesn't mean that it is this point. This point here is going to be your sample mean plus this here, this length here, from here to there is the 49. It's from here to here. That's 49. So what would this point be? And what would this point be? It's also going to be from here to here. It will be exactly also 49. So you will take 49 to the right and 49 to the left. And so 13, 15, we have to add. So 1,315 plus 49 is, so this point here is 1,364. And the point here, you have to subtract. So you subtract the 49. Okay, so here you subtract and you'll get 1266. So this point here is 1,266. Okay, so what is so special about what Leonids has done? Now Leonids can tell you with 95% confidence. So remember, this area here that you see is going to be 95% of the total area. Okay, so it's 0.95. And let's write it here. This is 0.95, and this is the confidence level. Okay, so she is now, we can say that Leonids is 95% confident that mu, the population mean, is going to be between 1,266 and 1,364. She can also write this as mu is inside or an element of the interval 1,266 to 1,364. And now what we have here is our confidence interval. It is this one here. We will call this our 95% confidence interval. So what does this mean? So now Leonids is 95% confident that the mu that we lost is going to be between these two numbers. Okay? So the mean of all the students in Zayed University on the MSAT is going to be anywhere from 1,266 to 1,364, and we are 95% confident of this, of what Leonids just told you. Very nice. So now, last thing Leonids wants to tell you before we take a break is she wants to make sure that you know how to interpret this result. So she's telling you approximately 95 intervals out of every 100 interval constructed around the sample mean will contain the unknown population mean. So suppose that this is the unknown. Remember this, we don't know what it is, we lost it. And what Leonids did is that she chose a sample of size 36. She just wanted to make sure it's above 30, but she chose 36 because radical 36 is 6. So it makes it easier to do the computations. But of course, she could have chosen any number bigger than or equal to 30 so that the central limit theorem works. Now look at what she gets here. She's only trying to tell you that if you repeat this experiment, what is the experiment? Is taking samples of size 36 from Zayed University students, which is your population in this case, then if you take 20, and of course the middle point that you see here is the X bar. This is the X bar, and it's different for each sample. You know, this we saw this in the last lecture. It's a random variable, this sample mean, because the sample mean varies from sample to sample. So all of these are X bars. And look at the intervals. How many of them contain the mu that we don't know? Count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. And how many of them don't contain it? You could be not very lucky and your sample would be an unusual sample, so that the population mean is not inside it. See, here the population mean is inside all of the 19 intervals, but there is one interval that it's not inside. It could be, of course, you could repeat this experiment a lot of times. Sometimes you might have all of them inside, even though it's 95% confidence. But on average, you should expect one of them might not contain it if you repeat the experiment 20 times. The reason is, you know, what is 19? So 19 over 20. So 19 over 20. If you want to make it out of 100, you multiply by 5, because 20 times 5 is 100. So this is the 95 confidence level. Okay? So 95, if you do the experiment 100 times, taking 100 samples of size 36, then 95 of them will probably contain the population mean, and 5 of them only will probably not contain the population mean. So I'm very grateful to Leonids, because she made my job much easier to make you understand this. But you can re-watch this again and again to make sure that you understand it better. Now you can take a break for 5 to 10 minutes, drink coffee, yoga, exercise, sleep if you can sleep and wake up in 10 minutes. Or if you feel that, okay, I got the idea and I want to watch later, that's fine. Just when you watch later, make sure that you understand what Leonids did. Okay, I will start after 3 seconds. Continue. Okay, so in these slides, you can read these slides, because all of what Leonids told you is written here. Okay, so you can see everything that she said here, plus a little bit more. Okay, but I want you to just know that you have 2 types of estimates. The interval estimate, that's the confidence interval that Leonids showed you how to do, with confidence level 95%, but you know, you could choose 90% or 80% or 99% or 90% confidence. It's up to you. But there is something called a point estimate, and that's when, if you are a very lazy person, what you can do, of course, Leonids is not lazy. She did all of this computation by herself. But if you are lazy, what you will do is you will get your sample mean and then immediately say that, okay, so the population mean is approximately the same, 1315. I don't want to work on confidence intervals and so on. But let me tell you, using 1 point only to estimate the population mean gives you 0% confidence. This, you'll be 0% confident that your mu is going to be the same as x bar. Okay, the probability that x bar is a specific value, in this case mu, is 0, because we know that the probability that a random variable is a specific value is 0. Okay, watch one of the videos that I had before when we were solving exercises on normal distributions. Then I showed you why the probability that the random variable is one value is 0. So if you are 0% confident, like that's like nothing. So it's better to avoid using point estimates and always use, like what Leonids did, use confidence intervals, so that you make an interval around, you make an interval around the sample mean, and you know that mu will be somewhere. Mu could be anywhere here. Okay, and you are 95% confident that mu is inside this interval. You cannot be 100% confident of anything. Okay, so yeah, you can read these slides. Everything here is simple. Okay, in this course, you will only learn how to use the sample statistic, that is the sample mean, to approximate the population mean. The other ones, these can be done, but for more advanced courses. Not really more advanced, they are simple, but just for the time constraint, we just show you the main idea, and the other ones will follow similarly. Okay, here they tell you also, do not expect that the point estimate is exactly equal to the population parameter. Like, do not expect that X bar is going to be exactly mu. This you cannot, 0% confidence. Okay, continue reading. All of what is written here is stuff that Leonud already showed you. This already she showed you. Already showed you how to get 1.96 using the online calculator. Already showed you that we call it Z sub alpha over 2 or Z sub C, the critical value. Okay, and here I'm giving you, now it's me. If you want to think that this is still Leonud, okay also. So here I'm giving you several levels of confidence and what their critical values are. So please practice on using the online calculator to get the numbers here. Okay, so this is given, all of them of course, given. Suppose that you want 70%, 75, 80%, 85, 90, 95, 98, 99% confidence, and use the online calculator to find the critical values for each. Okay, so here I give you 4 of them, and both using C where you do between, or alpha where you do outside. And notice the numbers that you get are the same. So for example, if you are 70%, you want the 70% confidence level, then you will get your critical value to be Z sub C or alpha over 2 equals approximately 1.0, and then 3.6 makes it 4. Okay, if you want, usually Z scores are taken to 2 digits after the decimal. So 1.04, and you can check here, yes, it's 1.04. Okay, and I'm showing you also 90% confidence, 95 and 99, and those usually, the 90, 95 and 99 are the ones that people use most of the time. Nowadays, they also like to use 99.9% confidence. So try also doing 99.9% confidence. This is your job, okay? But you have this picture here that shows you everything and how to use C or alpha. It doesn't matter. Okay, so here, let's say when you use alpha, call it Z sub alpha over 2. When you use C, call it Z sub C. But just know that it's okay to call it any of the two. So let's check quickly. What about here? The Z critical value, Z sub C equals approximately 2.576, so 58. Then you will go back and check that, yes, it's here, 2.58. So please do all of them. Now, you can take a short break doing them, of course. Check all these numbers and try to check them with C and with alpha. For alpha, you do the outside. For C, you do the between. Okay, check that you get the same numbers as the ones that we have here. Okay, I have a feeling that you're understanding this. Now, take a short break. And I will continue. You pause the video. I will continue in 3 seconds. Okay. Last thing before we start solving examples is reminding you of the margin of error and how to get it from the sample, from the confidence level. So suppose that your confidence level is 1 minus alpha. Okay. We don't want to give a specific number. So what you do is you compute the critical value, Z sub C, or if you want to call it Z sub alpha over 2, and you multiply this, remember, by sigma x bar. But what was sigma x bar? That was sigma over the square root of the sample size. It's a very simple calculation. Okay, sigma is known in this lecture. If you remember, I'll just go at the beginning and remind you that what we're doing today is when sigma is known. The next lecture will be when sigma is unknown and mu is unknown. In this case, it will be a very interesting question. So watch the coming video because it will teach you how to really do it. Because in most cases, sigma is unknown. Okay, most of the cases. So now we are where we got here, yeah. So go back and see what Leonud did. So there is a name. The lower value of the confidence interval, you call it the lower confidence limit, and the upper value, you call it the upper confidence limit. So for Leonud, what was the lower confidence limit? Let's see, yeah, this was her lower confidence limit. Is this, and this one was her upper confidence limit. Okay, remember this was this when you write it like this, you can see the lower confidence limit and the upper confidence limit immediately, or some people write it also like this. They just say the population mean is between these two numbers, or you can say it's inside the interval. Good. So let's now, now we can go to examples. This is the last slide here is the steps that you do. So first, make sure that the central limit theorem can be used. Either the population is already normally distributed, or if it's not, or if you don't know, then make sure that the sample you take is large, that is more than or equal to 30. And we suggested taking 36, or 49, because radical 49 is 7, or 64, because radical 64 is 8, or 81, because radical 81 is 9, or 100, because radical 100 is 10. You know, you can choose easy numbers that have a whole number square root. And here it's showing you the entire formula, okay, where this is the margin of error. You subtract it and add it to the sample mean after you compute the sample mean, okay? Very simple stuff. Now, let's solve an example. So this example says that Zayed University's admission director wishes to estimate the mean age, so we want the mean age of all students currently enrolled. Okay, in a random sample of 20 students, so it's less than 30. So we know that N, this sample has 20 students, so we must read somewhere that our distribution is normal. Otherwise, we cannot apply the central limit theorem and we cannot find the confidence interval, as you know. So let me see from, normally distributed. The population is normally distributed. Happy face, because we can use the central limit theorem. Good, it's applicable in this case. But now they're asking you to construct a 90% confidence interval for the population mean age. Of course, let's just find the given. So the mean age of the sample of 20 is 22.9 years. This is our X bar. It is 22.9 years. So this is an age. And from past studies, the standard deviation is known to be 1.5 years. So the population standard deviation, of course, in this case, is 1.5 years. And we want confidence level 90%. Notice that these numbers will give me the confidence interval. If you look here, you need X bar, sigma, N, and what else is given? The confidence level. What does this help me find? It helps me find Z sub alpha over 2. Or we call it also Z sub C, if you remember, also the Z sub C. So now the first step is find Z sub C, or sub alpha over 2. So the critical value is, and I have 90% confidence, so I go to the calculator. I will put here 90%, so 0.90, and I want between. So, of course, value from an area, because the area is the confidence level. So it turned out to be 1.645. You can say 1.65, but let me take it as it is, 1.645. And so the margin of error, E, remember it was this critical value times sigma X bar. So this will be 1.645 times sigma X bar is sigma, which is 1.5 years, divided by the square root of the sample size, which is 20. And let's see what we get. So we will what happened here? Okay, so we will go to our calculator, and the calculator, I'm sorry for this one. So we'll go to the calculator and do this computation. 1.645 times, I need a fraction, 1.5 divided by the square root of 20. Okay, so I got 0.5517. Okay, let me take 4 digits. Margin of error, you can take 2 digits if you want. Usually you match the margin of error by what is given here. We have 1 digit after the decimal, so you can match it to 1 digit after the decimal, but you want to be more accurate. So because I want to be more accurate, I will take 4 digits after the decimal. Okay, it all depends on your taste. Okay, so therefore we are 90% confident that our mu is where. So the confidence interval, you can say the 90% confidence interval is, and remember it was, you take x bar, subtract the margin of error, then x bar add the margin of error. And so this will be, let me choose a different color when we're doing the last step. What is x bar? It's here, 22.9. So you'll do 22.9 minus the margin of error is 0.5517, and the same thing, but you'll add it, 22.9 plus 0.5517. Let's see what this is equal to. So it will be, okay, I have a space to write, so I will just put it underneath. So this will be, I'm assuming that you're writing with me from the beginning. So please don't just watch. Get your hands dirty, please. Okay, so let's go to the calculator and see. After this calculator, I will show you something very nice. Okay, you will love it. So 22.9 minus 0.5517. Notice that you'll do it, and then the second time you don't have to do it. You just change the minus to plus. The numbers are entered already. So 22.3483. So, okay, 3483, comma, and then you go to this minus and make it a plus. So up to 23.4517. You can also say approximately 22.3 to 23.5 if you want just to 1 digit. Why did I choose just to 1 digit? Because, you know, X bar and sigma, all of them are to 1 digit. Both of them, I mean, up to 1 digit. So take 1 digit. Okay. But you can take more digits. It's up to you. As I said, it's up to your taste. So now, what can we conclude? You can say, listen to me and write this down. You can say, therefore, we are 90% confident that the mean age, or the true mean age of all students in Zayed University is inside this interval. And of course, if we repeat this, it's better to say, when you repeat this experiment 100 times, 90 of them will contain mu, and maybe 10 of them will not contain mu. Okay, good. So this is the answer, 22.3 to 23.5. Here is the classical way to do it. 22.3, 23.5. It's done in detail. You can read it. The interpretation that I just said is here, and it's showing you the picture that Leonids showed you, a similar one to it before. So please read this carefully. But now the surprise is that you can actually do this on the online calculator without having to compute anything. So let me show you how to do it. Okay, so we will go to the online calculator now. Okay, you will be very pleased with this. So now we just will put the numbers. 90% confidence. First, value from area. I want 90% confidence. What is the mean here? Okay, the mean is, remember, it's the sample mean, of course, 22.9. So you'll put 22.9. Okay, standard deviation. This is sigma x bar, which is this number here. Okay, so we will compute it now by the calculator, because I didn't actually compute it. I multiplied it by the critical value immediately, so we didn't see what it is. So let's just find it. So it's 1.5 divided by radical 20. That is sigma x bar. So 0.3354. I'm going to enter 3354, okay? So let's go and put 0.3354. Standard deviation 0.3354. And just do between. Look at the answer. And compare it to the answer that we got. 22.348 up to 23.452. And you see it's approximating it precisely. How is this now? Do you like it? I'm sure that you like it. So you can solve any problem that requires you to do confidence intervals when the population standard deviation is given using the online calculator. Only thing that I want you to know is this: the standard deviation is the one that you need to pay attention to. Make sure that you divide the population standard deviation by radical sample size. In this case, the sample size was 20 and sigma was 1.5. And this is why the one that you put here is not just sigma. It's sigma divided by radical 20. So remember, we did it here. Sigma divided by radical 20, and we got the 0.3354. I hope that you enjoyed this example. And after this, of course, I give it to you in both ways, whether you want to use confidence level or significance level. Okay, but remember, for significance level, you will put outside. For confidence level, you will put between. Just remember that. And how to compute sigma x bar, I explain it here also. Don't forget this. Okay, practice as many times as you like. Please, you can change this 90, make it 95 and see what happens. Or make it 99 and see what happens. Of course, the interval will start increasing. For 95, it will be approximately somewhere here. Okay, so you will get this interval. So please compute it for 95 and for 99. Okay, I think that you understood it now. Take a short break and we will just do the last part after this. Okay, so our last example is this. And how about we solve it just using the calculator immediately? I think that you will be happy with this. So how about this? Why don't you try to solve it using the calculator now, doing exactly what I did in the previous example, okay? But I will do it now. So you can pause the video and try it and then compare your answer to mine. So it says, the life in hours of a 75-watt light bulb is known to be good, normally distributed. So we don't care now if the sample size is large or small, it doesn't matter. The central limit theorem can be used with a standard deviation of 20 hours. So we know that the population standard deviation is 20 hours. And then a random sample of 25 bulbs. So our sample has 25. It's nice because radical 25 is 5. Just remember that. And has a mean life. See, a random sample has a mean. This means that this is x bar because it's the mean of a sample is 1020 hours. This one, of course, is hours also, the standard deviation. Okay, and construct, now they want you to construct a 95% confidence interval for the mean. Okay, so there is nothing really to be done. Let's see, what we want is, remember the most important thing I told you not to forget is what is the standard error of the mean or the standard deviation of sample means. This is sigma over radical n. Sigma is 20 hours and the sample size is 25. Wow, that's a very nice number. So it's 20 over 5 and we know that this is 4. For what? 4 hours. So we are done. We can use the calculator now immediately. So you will now go to the calculator and you will put value from an area. Now we want 95% confidence. Our mean is 1020 hours. Our standard deviation is 4. Remember, it's here, 4. And that's it, just between. So immediately, therefore, our 95 percent confidence interval is, and you will write open parentheses, put the first number, the lower confidence limit, 1012.16, or you can say 1012.2, up to 1027.84, as you can see here. Just to show you, if you do it using alpha, you will put 5%, that's the level of significance. Everything else is the same, just outside. Is it the same number? The same two numbers? Yes. With a happy face. Because I have a feeling that you understood it now. And let's just compare our answer to make sure. 1012.16 to 1027.84. 1012.16, 1027.84. Okay, great. But please read this solution and remember how to do it step by step. But really, if you can use the online calculator, there is, I mean, it's important that you understand the concept. It's very important. But for these types of questions, you can do it without doing all this stuff. Yet, I can still ask you questions where you cannot jump to the end immediately. There are some certain questions that ask you for parts. There is something where ask you, just find the critical value. This could be a question. Or just find the standard error of the mean. Or just find the margin of error. Okay? So all of these are possible questions to be asked. And here I show you that you can get it in both cases, whether you use the confidence level or the significance level. And now it's time for Leonids multiple choice exercises. Okay? I'm not going to solve them because they are simple. Leonid is just trying to make sure that you are listening to her carefully. So all the 4 multiple choices are things that Leonid already told you how to do. And the most important one is number 4. But of course, Leonid wants you to solve all of them. So please solve all of them and send me your answers by telling me problem number 1 has answer whatever, B or A, whatever answer. Just say like this, 1B or 1C or 1A, like this, and send it to me and I will check. Okay? And the same thing, 2, 3, 4. Finally, our exercises, we have, I think, 2 pages of exercises. Yeah. Notice just that I put exercise 1, 2, and then I jumped to 4. The reason is because 3 is long, so it didn't fit in this page. So that's why I put 1, 2, 4. Okay? So please, now I am assuming that you have printed out the whole PDF. Remember, the PDF of the lecture is always in the description of the YouTube video. You can download it before you even start listening to me or to Leonid. Okay, so there are 5 questions. Please solve them. Or if you are not a Zayed University student and you just want exercises, take screenshots of these and solve them and send your professor. Okay, so these are the 5 questions. It's a very important question here, number 5. Okay, so we will have another video where we solve like 3 of them maybe, but please try your best to do them by yourself. Also, number 4 is very nice. Okay, I would say number 4 and the numbers 4 and 5 are a little bit different, and maybe you cannot use the online calculator immediately. You have to understand what the question is asking. So please try them and send me your answers, if you are my student, of course. And last thing that Leonid would like to tell you is thanks for watching. And if you want to see Leonid again in other videos teaching you some of the topics and concepts, please make sure that you like the video. If Leonid sees that there are 100 likes, then she will appear in a lot of coming videos. It's up to you. Please subscribe and put the notification on so you immediately receive when I upload a video, and like the video, please. And that will be it for this lecture. Please remember that The next lecture is going to be part 2 of this, where we don't know the standard deviation. The population standard deviation is also unknown. Both of these are unknown, the mean and standard deviation, and we want to approximate the mean. Okay, but this is for the next lecture. Thank you for watching and take care.